Hello everybody and welcome back. We're going to be doing another straight edge compass construction. Well, a couple straight edge compass constructions. As you'll see, I'm doing a bit of setup. I'm not explaining what I'm doing. Right now I'm creating an equilateral triangle. What we're going to show in this video, and that's why I'm going to do multiple examples, is that we can take any regular convex n-gon and create for ourselves a regular convex 2 n-gon. So I'll do it with an equilateral triangle, then we'll quickly make a square, and then maybe, I don't know, a hexagon, because that's another quick one to make. But I'll show you that this technique really does work. So we've got ourselves an orange equilateral triangle. That's a regular convex 3-gon. I'm saying we can make a regular convex 2 times 3, or 6-gon, so a regular convex hexagon. Now, there's other videos, there's another video I've got that shows you how to just make a regular convex hexagon, but this is going to use a different technique to that video. What we're going to do is we're going to create the circumcircle, because the nice thing about regular convex n-gons is they always, all their vertices all lie on the same circle. So we're going to get that circle, and then we're going to be able to make the 2 n-gon also have points on that circle. So, first things first, we need to get a circumcircle. And this isn't particularly hard to do. You just take 2 of the side lengths and get perpendicular bisectors. And where those perpendicular bisectors intersect is going to be the center of your circumcircle. Now, this will only work for things that do have a circumcircle. All triangles have a circumcircle, so not particularly interesting in this case. But what else? Regular convex n-gons, they have a circumcircle, whereas just any old quadrilateral doesn't always. So you can't be guaranteed that these perpendicular bisectors do intersect all the time. But if you know you've got a circumcircle, then you will get a nice little intersection point, and we can create a circumcircle. We're going to clean up a little bit of this. I'm going to leave the perpendicular bisectors because I'm going to need, actually, I'm going to need the other bisector, so I'm going to add him in now. Because we do need all the perpendicular bisectors because they are what help us determine the intersection points. Okay, so now I can clean things up a little bit. So now we have a line, or a bunch of lines. We have an equilateral triangle, and we have the perpendicular bisectors to each of its sides. They all intersect at this nice common point right here. And so we can create circumcircle. This as the center, and any of the other vertices to help us determine the radius, they all lie on this circle. Quite nice. Okay, so now we've got these, we've left the perpendicular bisectors in, we've left them in for a reason. The points where they intersect this circumcircle are going to give us the remaining 3 points to create our hexagon. Why does this work? Okay, well, let's think about it. The green lines perpendicularly bisect the orange lines, split them in half. So what we've got is a high degree of symmetry. And we're going to get, we also have altitude to this top point, or I guess this bottom point. You're going to have a right angle there. Splits the base in half. What have we've got an equilateral triangle. Or not an equilateral triangle, we've got an isosceles triangle. Doi. And so, since down here, it's probably best if I now grab the segment tool. And we'll make it dark gray, forest green. But now what have we got? We've got, with the orange line and these 2 green lines, we've got an isosceles triangle, which means these lengths are the same. They're the same as these lengths. The same as these lengths. So when we take everything away, get rid of our equilateral triangle, we have a regular hexagon. And this is indeed a regular hexagon. I'm going to add the circle back in, but this is a regular hexagon. Watch as it moves around. I'm going to keep the circle here because we're going to take this regular hexagon and now turn it into a regular convex 12-gon. How? The exact same technique. So we're going to need this circumcircle because it's the circumcircle of the regular hexagon. And we're going to need to perpendicularly bisect each of these side lengths. We'll keep the compass tool out. We'll just do all the these side lengths at the same time. We've got 1, 2, 3, 4, 5. I'm missing 1. I feel like I'm missing. There it is. Alright, there we go. So we've got all 6 sort of petals in here. Okay. So we can get these intersection points out here. Create perpendicular bisectors. And so that's all 6 points there. So let's get those lines running through here. In the center, I think this is just a coincidence because of the hexagon. There we actually have all the lines there. Okay, so now we've got the intersection points of the perpendicular bisectors with the circumcircle that we started with, the circumcircle to our hexagon. Gives us the other points. Now we just grab the line segment tool. We'll make them cyan, the light blue. But connect these all up. And thanks to a high degree of symmetry, isosceles triangles, you're welcome to prove this stuff at home. This is more about the construction. We get ourselves a regular 12-gon, and I need to remember not to double click on points. Okay, so let's hide a bunch of this. You know, we don't need most of this. We can even hide our hexagon. We'll even hide the circumcircle, but what have we got? We've got ourselves a regular 12-gon. Now, it's kind of hard to see, and possibly on low-resolution videos, you might be mistaken this for a circle. But this is a regular 12-gon. We can repeat the process, get a regular 24-gon, but that would be very hard. It's going to take a lot of work. I mean, you do have to do perpendicular bisector for every single side and everything like that. But you can certainly do it if that's something you want to do, regular 48-gon, that sort of thing. But this technique works with everything, not just the nice equilateral triangles and the nice hexagons. So I'll even show you how to do it. I'm not going to do it with the pentagon or any of the other ones, just because that's going to take a while to set up. So I'll show you how to do it with a square, and show you that this technique, it really does work. So let's construct ourselves a square. So quickly get a square going here between these points, or with side length from these points. So there's one perpendicular line, and now we need the perpendicular line going through our second point. Fantastic. And now these circles here give us the other points that we need. So let's make most of this invisible so as not to detract from what we're going to do. We're just going to start again, but with a square, which is a regular four-gon. And from that regular four-gon, so let's get the segment tool out again. We'll start with another orange one. From this regular four-gon, we'll create a regular 2x4 or regular 8-gon. So there we have a square, not unlike the squares that I've constructed in other videos. Okay, so what did we need to do? Well, we need to first fix the colors on the line segment tool, but we need to perpendicularly bisect all the sides. We need two perpendicularly bisected to find the center of the circumcircle, but we're going to need all of them eventually anyway. So might as well, oops. That point was off. We can't have that. So there we go. So we'll need all of these. Just pick intersection points. So with the hexagons, we got quite lucky that all the 6 circles we drew intersected at the same center point. But as I said, that's only for hexagons that happens, which is quite nice. Very nice property. Hexagons have some very interesting properties. But let's get these perpendicular bisectors. If you're working with an even-sided n-gon, you'll only have half as many perpendicular bisectors because they'll have the same line multiple times. So we're not going to draw those. So we've got our intersection point, and that gives us the center of the circumcircle. So let's get rid of these circles that we use to find the perpendicular bisectors. And we're going to draw in that circumcircle. Center to any corner of the square. We kept these perpendicular bisectors around because they are going to give us the points on our regular convex 8-gon that we're missing, or regular convex octagon. And what color should the octagon be? Let's make it a dark gray. Just use the segment tool. Don't double click. Always double clicking. Of course, if you're doing this with pencil and paper in real life, how could you possibly double click? But the program thinks I want to relabel a point or something. I don't know. But we got ourselves a regular octagon, and let's enjoy it by hiding all our other work, including the square we started with. And of course, you could do this technique again, get yourself a regular 16-gon, and it just works over and over again. Oop, there were some points hiding. I always forget about the off-screen points. But there we go. We've got a regular convex octagon. And I think that's pretty nifty. And hopefully you guys think it's nifty too. Try it out on your own at home with your own straight edge and compass. Thanks for watching, and I will see you guys next time.